Hello and welcome to this brief lecture on water quality. Not only will we be talking about water quality or the quality of water, we'll also later in the lecture discuss what conservation is and specifically what water conservation is. In order to do this lecture, you will have to be answering some questions as we go through it. The questions are here. And you will want to, on a separate piece of paper, write these questions down. So feel free to pause the video at this point and write these questions down. You will be responsible for answering these questions as the lecture commences. Briefly, these questions are: what is water quality? What is hard water? What is turbidity? What is one indicator of biological water quality? What is the source of all water pollution? What is it like where we live? What is water conservation? And finally, where does the water you use come from? So to begin, question 1, obviously, what is water quality? It is the chemical, physical, and biological condition of water. It also happens to be a crucial factor in the quality of your life. And not only your life, but the life of everyone on the planet. Water is one of those necessary components to live. And so a couple images here. We have some people testing water, what looks to be like in a wetlands, some flowing stream, maybe not unlike our local river, and people drinking water, and obviously what happens if water ends up having other things other than water in it. So we will begin first by discussing what the chemical properties, or how you can have a water quality that is more chemical in nature, and this will harken back to us thinking about the difference between chemical and physical properties of things. So the chemical water quality typically deals with things like pH, which we've just learned about. It also deals with how much oxygen is able to be dissolved in that water. And finally, you can also talk about what is hard water versus what is soft water. It turns out, and this is one of the questions that is on your sheet, it turns out that hard water contains lots of minerals. So things that are dissolved in that water that many times have come from maybe where that water has been stored and has been dissolved in the water. Hard water contains lots of minerals, things like calcium and magnesium. And those are usually, as mentioned, dissolved from the things that the water is in. We will eventually be talking about aquifers, but if something is stored in a calcium aquifer, usually it will dissolve some of that calcium, and that calcium will end up in the water. So places in the Midwest, for instance, where water is stored underground in large caverns made of rock, over time, that water can dissolve that rock, and you'll end up with a much higher concentration of calcium and magnesium. And so hard water is something that has a lot of that, and it can cause things like corrosion, but also can cause buildup in the piping in your house and things like that. Soft water, by comparison, is water that has a very low amount of minerals in it, almost no calcium or magnesium. It means that the water is more pure. And it turns out here in Fort Collins, we actually have soft water. We do not have a lot of calcium or magnesium. We do not have to worry about this too much, like calcium buildup or lime or rust buildup in our piping, because we have very pure water here. It does not sit, our water that we drink rarely sits in underground caverns, dissolving the rock around it. Doesn't happen very often. So that's the difference between hard and soft water, and that is a brief discussion of chemical water quality. Let's now look at physical water quality. So think back to the physical characteristics, physical properties of matter. That would be things like the temperature, the color of the water, the odor of the water, because yes, it can have odor, it can also have taste, right? If we think about the difference between hard and soft water, hard water, going back, which has a lot of calcium and magnesium, tastes different than soft water or pure water. So it could be odor or taste. It could also, and this is one of your questions, be cloudy or hazy, right? And so that is what turbidity is. Turbidity is actually the measurement of how cloudy or hazy water is. Like maybe you have dirt kind of floating in your water that can make it turbid or turbidity. Here's an example of some samples of water going from low turbidity, so very clear, crystal clear water, slowly moving up to high turbidity. And so if you have turbid water, that is water that you can't really see through. It's in fact sometimes so cloudy that you can't see anything. If you think about, snorkeling or swimming in the Mississippi River, for instance, the Mississippi is notoriously turbid or very brown and kind of muddy looking. You wouldn't be able to see your hand in front of your face. Whereas if you went into maybe a high alpine lake in Colorado, you'd be seeing more of a crystal clear water. And so finally, we've talked about the chemical properties, we've talked about physical properties. We also have biological qualities of water. And so that is essentially what lives in this water. And so it's also a measurement of what is living in the water. And so that could be a measurement of bacteria. So if you think back to your biology, tiny single-celled organisms many times can cause disease, these bacteria. So things like E. coli or fecal coliform. If you are experiencing or coming into contact with water that is of low biological water quality, you might have water that has a lot of E. coli or has been contaminated with some type of coliform, right? This is one source or one time where you can have water actually poison you or make you sick. You could also have insects living in that water, right? You could have mayflies or mosquitoes. It can also be contaminated with invasive species. So this is actually a picture of zebra mussels, which are an invasive species that have taken over much of the portions of the waterways in the U.S. And these are all indicators if you're looking for a question answer. These are all indicators of biological water quality. How much bacteria, insects, or mollusks do you have in that water? So, how can water become polluted? It can be polluted in multiple ways, and the difference between them is shown here. So you can have point sources or non-point sources. Point source pollution is straight up a factory dumping waste directly into a waterway. Okay, so that's why this is showing your point sources as direct contamination. So let's say you have a wastewater treatment plant that is not operating properly, and it is dumping some type of contaminated water directly into a water source or a waterway. That would be a point source. It is on point directly from where the pollution is coming from. Conversely, non-point sources generally come out over large areas of land. So that could be rain falling over time on cropland. That cropland had maybe some type of fertilizer put on it, and over time that water will flow underground and eventually make it into this waterway, right? So think about spraying down your city streets with that are full of oil or other chemicals, and it rains, and that runoff will eventually collect, let's say, in its watershed and work its way into that waterway. So these are all similar ideas. Non-point sources, large areas of land that generally happen over time when things are leached out of the soil or drained off of streets or collect in one common source, eventually making it, versus point sources which directly are being pumped into water source. I want you to take a moment now and watch this video, which should be linked on this video, or you should see a link to it on this YouTube video. Go ahead and take a moment and watch that video. So now we will talk about the primary source of water pollution. Turns out to be humans. So that is the answer to your fifth question. All water pollution is caused by humans. And so both point sources, which would be those factories or leaking septic tanks or spill, or the non-point sources, right? Agricultural runoff, erosion of soil, runoff from streets. All of those things are human sourced. And so your answer to question number 5 is humans are the primary source of all water pollution. I want you now to take a moment and watch this video on pollutants, which should be linked on your YouTube video. So now we will take a moment and near the end of this video and talk about our local water and also what water conservation is. So we'll begin by simply talking about where we live. Turns out here in northern Colorado, we live in a pretty dry place. It actually is, if you're talking about biomes, it is known as a semi-arid climate, meaning that we do not get a lot of precipitation. We don't get a lot of rain. We don't get an overabundance of snow. Water is scarce. Water is precious. Water sustains life. This is just a typical image, right? You drive out east of Fort Collins, away from all the buildings, and this is what it usually looks like around this time of year, this late fall. It's pretty brown. It's pretty dry. You're not seeing lots of lush green forests around here. And so it means that water should be conserved. So take a moment, answer the question, where do we live? These are all fair answers for that question. So what is water conservation, or what does it mean to conserve? Simply put, to conserve something means to save something. And so water conservation, in a nutshell, means to save water. And so if we look at a typical usage pie chart of how much water we are using in a residential person, 24% of the water we use goes to toilet, 8% other, 12% is lost to leaks, 17% is used in washing clothes, 19% is used out of the faucet, 20% in the shower. To save water, you have to make changes. And so where could you potentially conserve water looking at this chart? In my mind, in every category, right? Definitely the obvious one is fixing leaks, but you can find more efficient toilets. You could take shorter showers. You could water your lawn slightly less. You could find a better way of washing your clothes. All of these things are are ideas of conserving water, and the list is endless. We need to conserve water here in Fort Collins because we don't have an overabundance of water. As we talked about a couple slides ago, we live in a very dry environment. It turns out we take our water. A large portion of our drinking water comes from the western slope. We live on the eastern slope of the Rocky Mountains. If you look, here's Fort Collins, looking at this map, this is a topographic map. If you look west, so toward Estes Park and beyond, we actually, through tunnels, pipe a lot of water from the headwaters of the Colorado River. So one of our major sources of drinking water, and this is the last question on your sheet, one of our major sources of drinking water is the Colorado Big Thompson Project, meaning we take our water from the other side of the mountains, pump it through so that we can use it. The other is the Cache La Poudre River, so this Poudre River down here. That's our other source. Now we will go into this in more depth in the assignment that you're going to start after this presentation. It's all about the Colorado Big Thompson Project. And there are several maps here that you will be able to look at. You're going to be creating your own after you do some research. This is one of those pipelines that will take water from the other side. What I want you to do now, however, is follow the final link to watch this animated history of the Cache La Poudre River. And after you're done watching that, you can move on to the next assignment.